For my pencast, I did problem 14 from homework number 1. The problem reads, what is the amplitude, frequency, and wavelength of the wave in this figure? Because you can see that time is on the x-axis here, we know there's a history graph. The problem gives us that it's a history graph at the point x0, and that the wave speed is 2 meters per second going to the left. So over here I started by making a list of knowns and unknowns. The problem here is asking for amplitude, frequency, and wavelength. Here we can see that the period is also an unknown, but you can figure it out from the graph. Also, velocity was given, going to the left. So to start, we know that amplitude is going to be defined as the max displacement, which is the difference between peak and point of no displacement. And so you can see pretty easily from the graph that the peak is here, and no displacement would be here. So that's a difference of 6 centimeters. So amplitude is equal to 6 centimeters. For frequency, we know that it's just going to be the inverse of period, and period is just going to be defined as the amount of time it takes to complete one complete oscillation. So starting at the peak here at time 0.2, and you can see that it takes 0.6 seconds to get to the same peak at 0.8. So t is going to be equal to 0.6, and if you take the inverse of that, you can get frequency. So frequency is now equal to 1.67 hertz. And lastly, to calculate wavelength, we can see this equation over here, which is just a distance equals rate times time equation. Our distance here is the wavelength, rate, velocity, and time is just going to be the time for one period. You can find the wavelength, because the wavelength will occur over the period over the time of one period. So just copying down the equation, that's velocity times the period. And we get a wavelength of 1.2 meters.